Well, hello everyone and welcome to my tutorial on how to check if a number is prime. In the previous video, we learned what prime numbers are. We learned some of sort of their properties and their definition. And here we learn how to actually check whether a given number is a prime or not. So basically, we check the primality or the primeness of a given number. Remember from the last video, we said prime numbers are natural numbers, and we said natural numbers are numbers which are not negative, numbers which are not imaginary numbers, which do not have decimal point, and they can't be fractions. So basically, natural numbers are the numbers that we can use for counting. So 0, 1, 2, 3, 4, and so on and so forth. So if I ask you how many friends do you have, you don't say I have minus 1 friends or I have 1.5 friends. No, you can say, maybe if you don't have any friends, hopefully not, but if you don't have any friends, you can say I have no friends, which means you have 0 friends. Or you can say I have 1 friend, 2 friends, 3 friends, and so on and so forth. Um, so these things, if for example you are given a number that is negative or has a decimal point, then straight away you know it's not a prime number. That's what I'm saying here. Prime numbers are natural numbers. The only even prime number is 2. So if you remember, the series was 2, 3, 5, 7, 11, 13, and so on and so forth. And I'm sure you know what even numbers are. Even numbers are numbers which can be divided by 2, and um, we get a whole number out of the division, i.e. there is no remainder. So all even numbers can be divided by 2. If the number is even and it's not 2, then it's not prime. The only even prime number is 2. This point here is basically just an extension or an expansion of this point. So what I'm saying here is a number is not prime if it ends in a 2, 4, 6, 8, or 0. So or if the last digit of a number is 2, apart from 2 itself, of course, 2 is prime. But if we have a digit that ends in 2, 4, 6, 8, or 0, then we know immediately it's not prime. So for example, if the last digit of a number, for example, is 2, then it's not prime. If it's 4, it's not prime. If it's 6, it's not prime. If it's 8 or 0, it's not prime. You know immediately it's not prime. Another point to notice, that if a number is divisible by 3, if we can divide it by 3, then it's not prime. Now, how do we know whether a number can be divided by 3, i.e. without having a remainder? If a number, how to check whether a number is divisible by 3? So what we do is we just sum the digits of that number. If the sum is a multiple of 3, then that number is divisible by 3, and therefore it's not prime. So for example, if I give you a number, for example 363, then when you add 3 plus 6 plus 3, that's 12. 12 is a multiple of 3. 12 is divisible by 3, and therefore this number here is not prime. If I give you, for example, 1 1 3 2 1, then 1 plus 2 plus 3, that's 6 plus 1 7 plus 1 8, then you can double check that that's not divisible by 3. But if I add, for example, a 4, then 4 plus 1 is 5, plus 1 is 6, plus 3 is 9, plus 2 is 11, plus 1 is 12. So this number, the sum of its digits is 12, i.e. it is a multiple of 3, and that number is divisible by 3, and therefore it's not prime. I hope this is making sense. The next point is no prime number greater than 5 ends in a 5, i.e. if you have a number which is not 5, you check the last digit of the number, as we did for this point here. You check the last digit. If the last digit is 5, then the number cannot be prime. So for example, if I give you a number like this, something like that, anything, and then the last digit is 5, then you know that it's not prime. The only prime number that ends in a 5 is 5 itself. Yep. We move on. So we have a technique now to check if a number is prime. We check the points from the previous slide, i.e. if it's not natural, then it's not prime, i.e. if it has a decimal point, or if it's a negative number or imaginary number, immediately it's not a prime number. If it ends in a 2, 4, 6, 8, or 0, then it's not prime. Always remember, By the way, 0 and 1 are not considered prime numbers. 0 and 1 are not prime. The only even prime number is 2. Any even number apart from 2 is not prime. Ends in 2, 4, 6, 8 or 0 is not prime. If it's divisible by 3, it's not prime. If it has 5 as the last digit, except 5 itself, if it has 5 as the last digit, then it's not prime. Moving on from that, what we do is we take the square root of the number, especially if we have a large number. We take the square root of that number, then we try to list all the prime numbers less than the square root, and then we try to divide the given number by those prime numbers which are less than the square root of the given number. The reason we use the square root is that, for example, if the number we are given, if we factorize it, if we just break it down into its factors, and if one factor is larger than the square root, then the other factor must be less than the square root, and we will find it first. That's why we take the square root to save ourselves time. This is just a clever technique, basically. So we take the square root of a number, and then we try to divide by all the prime numbers. Remember, all the prime numbers less than its square root, and we try to avoid 2, 3, and 5. The reason is no, that's not right. The reason is we avoid 2, 3, and 5 because we would have caught them here anyway. We would have caught them here in the first step anyway. Now, so remember, take the square root and try to divide by all the prime numbers. Remember, the prime numbers less than the square root of the given number, avoiding 2, 3, and 5. So enough talking. Let's take an example. Let's see, for example, whether the number 2311 is prime or not. So what we do is we can use a calculator, as you can see here, and we take the square root of that number. So the square root here saying is 48.7. As you can see, that's the square root. And then what we do is we try to divide by the prime numbers which are less than 8. By the way, we can check this number here. You can use these rules now. So it's not even because it doesn't end in a 2. It doesn't end. It doesn't end in a 2, 4, 6, 8, or 0. And it's not divisible by 3 because 2 plus 3 plus 1 plus 1 is 7. And it doesn't have 5 as the last digit. The last digit here is 1. So we can go ahead now with calculating the square root. And the square root, as you have seen, is 48.07. So we try to divide by all the prime numbers which are less than 48.07. This is a list of those prime numbers less than 48.7. Here I'm excluding 2, 3, and 5 for the reasons I explained previously, because we would have caught it using the points in this slide. Now let's try to divide this number by, I'm just trying to round it, so 48.7. If I divide by 7, then we don't get a whole number. If we divide by 11, we don't get a whole number. If we divide by I'm sorry, I don't divide the square root, I divide the number itself. So we divide the number itself. If we divide by 7, we don't get a whole number. If we divide by 11, we don't get a whole number. If we divide by 13, as you can see, if we divide by 17, if we divide by 19, again we don't get a whole number. 23, not a whole number. 29, not a whole number. 31, not a whole number again, as you can see. 37, not a whole number. 41, not a whole number. 43, not a whole number. And 47, not a whole number. And therefore we conclude that 2311 is actually a prime number. I hope the technique makes sense. Remember to check these points first, and then take the square root and then divide the actual given number by all the prime numbers less than the square root, and you avoid 2, 3, and 5 to save yourself time, because you will have caught it or you will have checked them already anyway. This is a list of prime numbers with up to 1000. Remember, 1 and 0 are not prime. We start at 2 and go all the way, as you can see, into with all the prime numbers until we reach 997, all the prime numbers less than 1000. Now if the number is too large, then you may of course need to use your calculator or use a computer program to actually check whether it's prime or not. Remember from the last video and this video again, prime numbers are extremely important in our day-to-day life. We use encryption either knowingly or unknowingly. We use it everywhere, over the internet, for bank cards, for communication, for radio signals and TV signals and satellite communication in general. Prime numbers are extremely important and they play a central role in encryption and in data protection. Thanks very much for watching, and I'll see you next time.